All right. Number 9 on the review. Here we go. Current comes out of the positive. Everything goes through A. You all right with that? So A has the most. Here we have a junction. So some of it can go to C, some of it can go to B. Okay? And here we have another junction. Okay? So, I've got 3 branches here. Which of these 3 branches have the least resistance? C's branch, D's branch, or E's branch has the least resistance? D has the least resistance because these 2 resistors are in parallel. These are like you've got for Walmart, you've got 2 options. Here you have 1 option. Here you've got to go through both checkout lines. Okay, so there's more current going through this one than this one, and that's the most resistance, least amount of current through that branch. Okay, is everybody okay with the fact that B has more current than D? Because it has to supply current for both D and E. Okay. How are we doing with saying A and L are the same? Whatever comes out of the battery has to go back into the battery. And for the same reason, B and M have the same amount of current. Good? Okay. So after B, then D and K. You right with that? After D and K, E and I. And after E and I, C, F, and J. Question though is, what about G and H? If you follow this single loop for G, there's only 1 resistor. Just like E. H, same story. So here's current going, supplying this is both going through D. It splits, comes back together for K. So G, H, E, and I are all equal amounts of current. Good? Okay. There are some questions on the PowerPoint that we have not yet touched on. I'd like to touch on those. I will give you this warning. They are more on the difficult side of the questions. So brace yourself. Okay. These are coming out of lesson 4. And then we'll jump to the end of lesson 6, actually the end of the PowerPoint. For the sake of time, I'm going to give you a chance to answer them, and then I'm going to tell you. Thumbs up when you have a guess. This is straight out of your lab. Correct answer is A. Here's why. In a series circuit, what's the same? Current is the same. So, power is going to be dependent upon voltage drop. If current is the same in a series circuit, the greater the voltage, I need to make that go up, resistance has to go up. So in a series circuit, the more resistance, the greater the voltage drop, the more energy it's taking, the brighter it's going to be in a series circuit. How are we doing? Okay, there. Thumbs up when you got something. There are many different ways to solve this problem correctly. Correct answer is 48 watts. Okay, one way is to find the total resistance, 12 ohms, 2 amps coming out of that, 2 amps, 24 volts, 48 watts. Probably the most straightforward way. Good? Tell your neighbor. Okay. Total resistance. So this is goes down. Total resistance goes down. Looking at the entire thing. If the total resistance goes down, the voltage, total voltage stays the same because it's determined by the battery. Therefore, your total current goes up. That current is the same throughout the circuit. So if you're looking at just this individual resistor, the resistance is staying fixed. The current is the total, goes up. Therefore, the voltage drop across this must go up as well. Good? Okay. Same scenario. What about the voltage drop across R1? speaking to R1, using Ohm's law gets a little crazy because there's not a variable that stays constant. We decrease the resistance, we increase the current. Okay, do you see the conundrum? Okay, here we had a value that was fixed, so we can conclude like, oh, if this happens, that happens. That's easy. Okay? If you ever find yourself in a scenario where like, I don't know, your fallback plan, your safety net is Kirchhoff's loop rule. That will always hold true. Okay? So, here we have, I'm going to say like 10 volts, 10 volt battery. Your ladder is 10 volts. That doesn't change. When we do this, let's say they start out equal. So it's like a 5 volt drop and a 5 volt drop. Voltage gain equals the sum of the voltage drops. Okay? We just said when we decrease the resistance on that, this voltage goes up. So that goes up to like 6 volts. Again, I'm making this up. In order for your voltage gain to equal your voltage drop, this has to be reduced to 4 volts. Decreases. Okay, don't be happy that you guessed right. Make sure you understand why that works. You okay with that? With like a definitive argument. You may run through that again. Total resistance goes down because we decreased this guy. Total resistance going down, voltage on the battery stayed the same, so the pressure is the same, so total current goes up. That increased current goes through R2, so the voltage drop across this one increases, taking more energy. Okay? Conservation of energy says you can't get something for nothing, so if we have more energy being taken out, there's a bigger voltage drop across this one. The voltage drop across this one must decrease. Good? Correct answer is D, dangerous dinosaurs. You have 2 ladders in 1 slot. Okay? You're adding up, doing the loop rule. Okay with that? Okay. To make a connection with life, when you load batteries, you alternate, yes? Okay? In the battery case, it's wired in series. So a device that requires 3 batteries requires 4.5 volts. Good with that? If you organize it wrong, you're actually subtracting voltage. It's like having an upside down ladder. Okay, good with that? Okay, skipping to 3 last slides. Okay, we did this one, yes? Okay. These are difficult. Thumbs up when you have a guess. Here we go. We've combined those two in parallel, yes. Okay. So this would be light bulb 1, this would be light bulb 2, 3. Okay. If I pulled 2 out, what's going to happen to the resistance of this green 2, 3? I pulled out light bulb 2, which is wired in parallel. If I take away a resistor in parallel, what happens to the total resistance? It goes up because I took away a checkout line. Is everybody okay with that? Okay, so my total resistance so I just made that go up, so my total resistance is going up. You all right with that? Okay. Looking at the entire circuit, total voltage stayed the same, 12 volts. Total resistance just went up, therefore total current went down. Okay? All of the current coming out of the battery goes through light bulb 1, which just decreased, causing the brightness to decrease as well. It gets dimmer. How do we do? Okay. Walk you through that again. Pull this out, that decreases this resistance. I eliminated a checkout line in Walmart. Total resistance goes up, therefore the total current goes down. All of the current coming out of the battery is going through 1. Gets dimmer. Follow-up question, same scenario. What happens to light bulb 3? So this, it's kind of a conundrum, because you're like, okay, the total current decreased, dimmer. Yeah, but before, current had an option. You go this way or this way. Now, all of it's going through 3. If you're like, Kirchhoff's loop rule. Okay? So I'm looking at this loop here. Alright, so 12 volts. Let's do original. Yeah, 12 volts. Okay, I have a 12 volt gain. That's my ladder. That's not changing. Okay, I'm going to make this up. Let's say I have a 6 volt drop and a 6 volt drop. Totally making that up. But they have to add up to 12. Okay? When I pull out this guy, the total current decreases, as we concluded from last question. Okay? So looking at this, the resistance of 1 did not change. The current through 1 did change. The voltage drop across 1 also decreased. So it went now from 6, it reduced to like 5 volts, totally making that up, but reduced. Therefore, this has to make up the difference. So this voltage has to increase to like 7 volts, making that brighter. Full on. Let me run through that again. And pull out light bulb 2. Total resistance of this green goes up. Total resistance goes up, which drives the current down. Total current down. Okay? So the voltage drop across this guy decreases. Across 1 decreases. Meaning that the voltage across 3 has to compensate for that. So that the voltage gain equals the sum of the voltage drops. Okay? So how do you express that in terms of current? So yes, the total current decreased, but beforehand, you got current going this way and current going this way. When we close this down, all the current now is going through this, and it happens to be enough to be more current than what it had before. And it gets brighter. Good? Last question. Know that I've given you information about one resistor. Thumbs up. You got something? Correct answer is 45 watts. Here we go. Ready? You know there's 2 amps going here, given to you. So you're missing information, voltage. You have 20 volts. This is in parallel. So also 20 volts. You're missing current. You can find that. Oh, that's 1 amp. Okay, so we have 2 amps going here and 1 amp going here. That at this junction must mean there's 3 amps going through that guy. 3 amps gives you 15 volts. Current times voltage gives you 45 watts. Boom. Okay? I need those, as you walk out, I need those quizzes and bubble, or the printout